Hi. So, you have to start talks with hi. My name is Chris. I like posting ridiculous selfies on the internet. I work as an SRE at a payments company called GoCardless. And today, I'm going to talk about supposedly obvious mistakes and why we make them. So I'd like to start by stating the obvious. We're at a conference, and I'm giving a conference talk. But I'd also like to talk about something more subtle, which is the idea that conference talks favor certain structures. And in particular, they favor self-contained narratives. Things like how we fixed the unfixable, or how we scaled our system by 100x. These are great stories to tell, but there's a lot more that goes into the story of our companies as we build them. In particular, it's very easy to admit the mistakes that we made along the way. The things that perhaps should have been obvious, especially. The things that all the conference talks told us, make sure you never do that. The mistakes that you thought you'd never make, except you did. And I hope I can convince you that this is normal. The reasons are often reasonable, and being able to talk about this openly is very important, because that's the only way to start fixing them. Before we launch into it, I want to set out my context and any biases that I may have going into this talk. Our companies are all different shapes and sizes, and this talk is firmly based in my own experience. Talking size-wise, GoCardless grew from 25 people when I joined to 215 now, and we've gone from 8 to 60 engineers. We're a payments company, and that's definitely influenced our thinking in certain ways. Most companies aren't payments companies, so maybe things will differ a bit. And I have a personal bias. I have 4 years' worth of hindsight. At the time, none of us had that, and everyone was acting with good intentions. So with that said, I'm going to structure the talk around 3 examples. For each example, I'm going to define what it is. I'm going to talk about what it may look like in your team, the problems it causes, and ways you may go about fixing it. At the end, I'll wrap up with some common themes and make some time to discuss things and go into Q&A. Probably in the hall now with the delays that we've had. So, let's get to it. Failure mode 1, early division of product and infra. So, you're a young company, and you've built this product. Your user base is growing, and all of the important graphs are going up and to the right. But it turns out, you've also built this other thing, and your product relies on it in order to work. It kind of caught you by surprise, and congrats, you have an infra. It takes up dev time. Sometimes it breaks, kind of catastrophically. And you weren't ready for this. So you ask yourself, is there someone who could make this problem go away? And you come up with the solution, which is, we need to hire a DevOps. And when I phrase it like that, it sounds kind of silly. But it is literally what happens at most small companies. I think my favorite stroke least favorite phrasing of this was from someone at a recruitment fair who said, we have all of this rubbish that isn't the core product, and it's distracting our devs, and they don't want to do it, and we just want to hire someone to do that. Would you like that job? And internally, I wasn't really sure what to say. I was kind of like, can you see how this might not be a good sales pitch? But while that person's phrasing of the role was kind of clunky and unappealing, it is quite a common framing. When people say we're hiring a DevOps, this is often what they really mean. They just won't say it to your face. And ultimately, it comes down to convenience. Hire a DevOps is a convenient lever to pull when you have these new infrastructure problems that you don't know how to solve. And they are real problems. Like maybe your users are unhappy about unreliability of the service, or your devs are unhappy because none of this is home turf for them, and they're unsure how to deal with these problems. So it's an understandable lever to pull, but it introduces new problems for you. In particular, it introduces organizational problems that you didn't have before. Perhaps the most important of these is that you lose a feedback loop from your product. You hand over production responsibility to this person, and you disconnect the rest of the development team from production, and they don't have that feedback anymore. You've now got a new bottleneck. Again, you've handed over all of this infrastructure responsibility to one person. So if you suddenly have more infra work to do, you have no way of getting that done. You have to go through this one person who will decide, well, I can do that, but like not the other 10 things that you need. And ultimately, you end up hiring more and more infra people to service that. And if you hire a load of infra people, as soon as that spike in work kind of subsides, you end up with time spare. And what do infra people do when they have time spare? They build more infra. And maybe your small company doesn't need that right now. 10 or 20 engineers should probably be using mostly managed services. So assuming you're in this situation, and I can't just give you the sort of glib advice of, well, unsplit the teams, it's fine. That may be impractical for your org now. I think where I'd start is trying to make it easier for people outside of your infra team to contribute to the infrastructure. You'll often have product developers thinking, I wonder if I could make that little change there, a change to routing or load balancing or something else just to get their app feature working. So make it obvious what they need to change. And for us, this came when we had a new joiner into our infra team. They arrived, and our code base was kind of scattered across 20 or 30 different Git repositories. Call it micro repositories, if you will. And it wasn't obvious how those linked together. So in their first few weeks, they kind of ran up against these brick walls and then fed that back to us and were like, could we improve this? So we did. We moved things into a monorepo. We improved documentation on kind of where everything lived. And what we started to notice afterwards was people from other teams were more able to contribute to our infra code base, which was very cool. Another thing that's important is experimentation. People need to know that when they're making changes to the infra, that they're not going to break it, and that what they want to do has been successful. Experimentation might come in the form of local unit tests or isolated environments to deploy it. People need access to both these things. And lastly, it's worth setting aside time to coach people who are not used to infra. I mentioned how this is not home turf for a lot of developers, but you can help make it so. I will break one of my own rules that I set myself. And I'm going to give you some upfront advice if you're in the position of making your first infra hire. If you're making your first infra hire, I would look for someone who has some background in software development as well, and particularly someone who is keen on coaching developers along the way. You want someone who can very easily interact with the existing dev team and help them meet their goals. You don't want to create a new siloed team just for the sake of it. And lastly, do not give this person sole ownership of the pager. This is a horrible way to run the team. You lose the feedback loop from the product, and if your infra team is 1 or 2 people, they're going to burn out on this. Failure mode 2, being distracted by hard problems. Here's some rhetoric that we hear super often. Join our company and solve all the hard problems we've got. This is in every job ad. Like, I don't care which company you're at, this is probably in your job ad. When you hear it often enough, you start to assume that hard problems are the most important problems to solve. But in reality, they often aren't. And I think there's an issue with that, which is that if you go after hard problems all the time, you can forget that the basics even exist. And when I say basics, I mean things that perhaps we consider kind of hygiene level, topics we would agree on as forming the core of SRE. And I'm going to pick on one of these, observability, as an example. I think it's fairly easy to agree that observability is a core part of SRE. So I'll run with that for this failure mode. Inside observability, I'd include things like metrics, monitoring, structured events and logging, that kind of stuff. Things that you use to try and meet your service level objectives. And if you're not used to the tool of service level objectives, think of them as your goals. You may phrase those goals in terms of uptime, or error rate, or perhaps latency, or something else. Improving your ability to observe your service is something that's very easy to defer. And I think the reason for it is that it feels like this kind of mundane work that doesn't move the needle anywhere. If you look at it as a project, like, okay, we want to sit down for a few weeks and do some work to make observability better, you can kind of have these conversations which go around in circles. So you ask, okay, how are we improving the service? And you go, well, it's better because we can measure the service now. And maybe you're like, well, how does that actually improve it? And you can't find the right answer there. It's really awkward. The reality is, it improves it over time. The payoff of observability comes over a long period. And it comes in the form of things like faster debugging when things go wrong, in the form of shorter outages, which should hopefully make your customers happy or less angry. And over the long term, it can drive your project choice into better places. You can look at where real pain exists and solve those hard problems instead of the ones that you think were most important, but without data. As well as feeling slightly mundane as a project, it can feel the same way as ongoing work. And I'm sorry to say that observability is ongoing work. Projects such as adding a new metric system may give you a step change, but in order to be successful, observability needs to permeate everything you do. So what problems can you run into when you forget about the basics and go choosing hard projects instead? Well, I have an anecdote, and it's from something we did. A while back, we built some automation to fail over between our primary database nodes, the ones that serve all of our API requests. And this automation basically means when we want to do patch upgrades to the database, we can flip over and no client requests are lost, which is quite cool. But in hindsight, I'm not sure that this was the best use of our time. The thing that downtime saves is a 10 to 15-second window of downtime. We would want to do that every month or two for patch versions of Postgres as they come out. Most of our users are in the EU, so we could probably do those at night and just stomach it for a while. What if we'd spent the time that we spent building that automation on getting better metrics out of our systems, improving monitoring and alerting, perhaps instrumenting like extra structured information out of the service? If we look at it in terms of the advantages that I mentioned earlier, we can flip them around, and the results of an underinvestment in observability is slower debugging, longer outages, and worse choice of projects long term. And it comes down to this thing of, if you lack measurement, you're going to lack confidence. And that's definitely something I've felt over the years. So how can you get yourself out of this? I think one really useful tool is post-mortem meta-analysis. If you write post-mortems after you've had an incident, then you're going to be writing down things like what went wrong and why it went wrong, and most importantly, perhaps, how you figured it out, how you found out where the broken stuff was. If you analyze all your post-mortems together, you can start to extract common themes. Perhaps they're all saying it wasn't clear where the problem was, or we couldn't break down this problem by which users it affected. Or, even more fun, it was a false alarm, again, at 3 in the morning. All of this is telling you that you can do better at the basics. You can shift your culture in some way and avoid real continuous pain that you're experiencing. And in this case, I think the shift comes in your definition of done. You should be thinking of your features as done not when they're shipped, but when they're measured, and you can understand how they're performing in production. And initially, that feels like a huge shift to make. But that's fine. Like, cultural change takes time, and you won't change how your team works overnight. The important thing is to start somewhere. It's easy to do nothing because you feel like you should be doing everything already. Maybe it's about including that metrics library and starting to emit some stuff from your service, or instrumenting that endpoint that's been giving you no end of problems. Now, I picked on observability for this, but there are many other basics, and each of them usually has some sort of tool or method for measuring whether you're doing well at it. I talked about post-mortem meta-analysis and how that can help you pinpoint failures in observability. But maybe what you need to do is track how much toil, that is, manual work done by your team on stuff that could be automated, is going on, to pinpoint systems that lack automation. Or maybe you should be tracking pages per shift to see if your on-call rota is in danger of being pushed into burnout. And in theory, everything I've just said should be really obvious, right? Like, it's all written down in a book with literally the same title as our job title. But often I find that this kind of work can be lost under kind of the new shiny, things that seem like they're really important, and they're hard problems, so we're biased to solving those over the basics. All right, failure mode 3, the everything project. And this one revolves around a story from about 3 years ago, and I think it illustrates this problem really well. Unfortunately, this is painful as heck for me to talk about. Collectively, as an engineering org, this was one of the hardest failures to admit to ourselves and do something about. But of everything I've talked about, it had the strongest and most immediate impact on our team. So I think it's a story worth telling. Let's go back to here. You have an infra. You're not happy with it. You feel that it evolved somewhat haphazardly. And you know where its problems are, and you really just want to fix them. But doing so kind of involves reshaping the core of your infra in some way, changing some of the most fundamental parts. And again, I can go back to something we talked about in public, which was how we run our applications in containers. In particular, in this talk, I talked about how we don't use a distributed scheduler like Kubernetes or Mesos to do this. But there's a part of this that the talk doesn't go into, which is the precursor project, the project that we ended up throwing away. We'd started with this goal of better, more reliable deployments, making things break less often. And since it was 2014, we'd landed on containers as the way of packaging up our apps and shipping them off to production. We'd heard that orchestration and Mesos was all the rage those days, so we thought, well, let's do that. Let's have something else decide which machines services should run on for us. Maybe if we drew the line here, we would have been okay. But before you know it, more and more stuff was being added to this project. We didn't like how load balancing was, so we thought, let's change that as well. And we'd always wanted to have like a separate staging environment for every developer that they could spin up and tear down at will, because that would be great. They could like have a whole GoCardless to play with whenever they wanted. And obviously, all of this should be behind like Heroku-esque self-serve UI. And before you know it, you're working on an everything project, which leads to certain problems. The biggest of which is that as soon as you have an everything project, everything in your org is seen in terms of the new world. So nothing happens back in the old world, back in the infrastructure that is serving your customers, the infrastructure that your developers need day to day. Every feature request in that infrastructure is turned down because, well, the new one will solve it when it arrives. And that approach feels really efficient. You think, oh, we're going to bypass doing all this like double work in both places, and we'll just jump to the good one when it's ready. But it's not. The efficiency of a project that you can never deliver is terrible. In the meantime, while we were doing this, our team had lost its impact. We weren't solving the problems that mattered now. Ultimately, we'd lost our own confidence, and the org was losing confidence in what we were doing. And our team morale was kind of in the trash. So if you find yourself in a situation like that, where do you go? And the hard part that we had to bring ourselves to do was to stop. Stop building and start talking about where we are. How did we get here? What's the value in what we're doing? Why does nobody in the team feel happy about what we're doing? What we ended up doing was looking for the small version of the project, the real pain point that had brought us to this in the first place, the valuable part that was hidden underneath all this extra rubbish that we'd tacked on. And for us, it was all about deployment and making that reliable. So we took the project and we gave it some focus. And we were actually able to ship something. And the real lesson here is that efficiency cannot come at the cost of everything else. The idea that you can skip and make this one leap into perfect infra is ludicrous and will just never happen. Ultimately, if your project relies on stopping the world, it's pretty much doomed from the start. And now, I won't go against the idea of long-term goals. These are good to have, but they're no use if they fail to acknowledge your short-term reality. And again, this is something that should seem obvious, right? This is a fairly famous blog post by Joel Spolsky from the year 2000, and it's practically programming folklore. It's like, whatever you do, don't big bang rewrite your system. But would you notice it if the rewrite crept up on you piece by piece, feature by feature? So I've talked about these three different categories of mistake, and I want to tie these thoughts together. I've presented three things that, according to programming and SRE folklore, are obvious. Yet we're not the first company that made these mistakes, and we won't be the last one, for sure. The reason companies make these mistakes still is that each one has a satisfying internal logic. I mentioned how conference talks favor self-contained narratives, and I think this is true even when we talk about mistakes. Technical mistakes are often quite self-contained. We had this outage, we figured out what was wrong, and we fixed it. They're easy to talk about, but they leave a lot out. And they can lead to this us versus them mentality. I often think you can sit in the audience of a conference talk and be like, yeah, I mean, so they had that technical outage, but they seem to be like basically a perfect org, and we could never be that. So I wrote this talk to dispel that idea because it's nonsense. And I hope I've convinced you that you won't avoid every mistake, because we certainly didn't. And It's never perfect, but it is perfectly fine to correct course. Thank you.